Ladies and gentlemen, good morning and welcome to the 2012 Annual FEDA Conference. I'm Philip Llewellyn, the manager of CAD Services at R.W. Smith & Company, and I would like to thank all of you for coming to this presentation about BIM and the impacts it is having on the food service industry. Let me start with an overview of exactly what is BIM. BIM is short for Building Information Modeling, an entire environment of tools which includes software we use for 3D modeling and clash detection, not a specific software. There are three main software packages we use at R.W. Smith, which are Revit, Navisworks, and 3ds Max. The intent of this presentation is to show a progression of what the return on investment is for these tools and processes. The first phase of any BIM process is to produce the base building model. Revit is the tool we use in-house for this task. Producing a model which is both accurate and detailed is crucial, as these are the base models which will be used for numerous different aspects throughout the building process. Now let me show a building which was one of the first projects we did in any type of BIM software. We're using Revit here and walk you through some of what the things that Revit can do. So what I'm doing now is turning off the object styles, or layers in AutoCAD is what they would be, so we can look inside of the building and see the kitchens. So we turn off the walls and give us 1 second. And here we go, and we can see that the kitchen equipment is there sitting nicely at the right height as the 3D requirements need to be. And now we're looking at the properties that Revit holds for each of these pieces of equipment, this one being a merchandiser. So we'll go to the first floor and show some more capabilities of how Revit ties the tags and other annotation directly to the 3D objects. So in this lakeside table, we have a number of different properties from material to height, width, depth, and here the tie mark is what the tags reference. So you can see as I change the tag number in the properties, the tags change in the floor plan. If I were to change the tag in the floor plan, the element properties would also update. It's all one and the same. Here we go to the schedule, which is also linked to the floor plans and the 3D view we can see on the left-hand side. And you can see there's a lot of information in the schedule, and this is adaptable to whatever needs you have for the project. So here, let me go and grab the EquiHeat banquet carter that we have, and we have a number of different materials again. You can see how that ties together, which then allows us, after we've spent this time, to produce a 3D perspective of what the final space is going to look like. And this is pretty true to form, and again, Revit allows whichever data is changed in whichever view to be changed in the other views all at the same time, instead of doing it manually like we used to do with AutoCAD. Clash detection is a process of making sure that all of the different building systems fit. What we use for that is, our main tool is Navisworks, which allows us to bring all of the different files formats together into a single program to make sure that everything has enough space to fit. So as I pan around of this clash detection model, we can see in yellow is the refrigeration food service component of this project, and you can see just how tight everything is and can get in these modern hospitals. We also have the ductwork is magenta, and electrical is blue, with mechanical systems being light green. So let me open up the clash detection tool, and here we can select, change it to a different view, and we'll select both the mechanical and refrigeration. Hit run, which clashes the different pieces together, and here we see the clash between the mechanical access zone and, for the refrigeration, seismic bracing that is required here in California. So it's green because the clash was approved due to this being a clearance zone for mechanical ductwork filters, and we were able to get away with that. Also in the lower right hand, where you can see the cursor going to occasionally, is the information as to exactly what those pieces are. So when I go to write a question or a suggestion, I can reference that in the coordination communication. So we're going to pan around a little bit more, and you can just see how much faster that this could be in the virtual environment, where I can make changes quickly, delete, move ductwork around without having a whole crew of people in the field trying to cut off expansion anchors and so forth. One of the promises of this suite of tools is lower costs, and clients have certainly jumped on that and also started to change their building delivery methods. And one example is changing from a sealed low bid example to a design build type building delivery. What we're walking through now is a restaurant we did for Disney in Southern California, and this building was split up into two different packages, one for the exterior shell and structure, and one for the interior build-out, which was my team. For this project, I was the BIM executive, which meant that I brought all the models together, provided a way to deal with the difference in coordinates between the two, and made sure that all of the models were up to a usable level of detail. Working with a client with a computer animation studio that's as successful as Pixar did present some challenges. One of the requests of the client was that we take this model and make it in such a way that it can be used in their virtual reality room for a virtual experience. We actually played this video in that room, walking through the model for a number of their executives and others. This is why the model has such a high level of detail. This model actually came from the interior designer who put it together. Due to this project's timeline and the amount of design changes that were happening, it was paramount to have the shop drawings attached to the 3D model as they are in Revit, because doing it in the old way with a 2D drawing that then we manually convert to a 3D model would have been cost prohibitive in this case, and also we would have had to make changes to the detail level for the virtual experience, degrading it. So now that the promise of more production with less cost has been made, what does it take to get there? The most important and most expensive part of it is the user base. A skilled user is absolutely necessary to maintain the office, the families, and to raise the level of all the individuals that are working underneath them. I myself have been using Revit for 8 years, and I started in the architectural industry working on small residential remodels that had very little economies of scale, very little copying and pasting, any repetition of that sort. After about the third project, we got the skill level, the knowledge of what the program could and couldn't do, and our library of different pieces to use, components as it's known, or families, which is what all these different pieces are representing. And we were slowly but surely able to increase our production and cost on each project until we were very, very easily faster than we were in AutoCAD and more accurate. And on top of that, we were able to produce videos as we were seeing. So that is the largest cost. And then we have, after that, we have the expense in software and computer hardware. And yes, it does require more expensive computers, but that's the least of the costs out of the different three. So what is the duration of time from the beginning of the implementation of Revit in an office, Revit, Navisworks, this whole suite, before you start to see a payoff? Well, I'd say it's a minimum of 3 years if you start from scratch. It can be a lot quicker. For instance, I've been working at R.W. Smith for 2 years and 3 months, and this work, again, is all that we did in-house. So it's very important to have the executive management engaged, because also there are many people at the office that are never going to be able to pick up these tools. For example, the last architectural firm I was at, I trained approximately 75 people, and maybe 5 or 6 were really proficient with Revit when I left. As we walk through our largest project to date, a $7 million mess hall for the military, you can start to see in the equipment detail that we have a much more robust library, and this is really where the payoff of Revit starts to come to fruition. All of this equipment has all of the features that we've had in the very first video where we were showing where the properties and schedules are generated from the individual pieces of equipment. I'd say roughly around 97 to 98% of the equipment that we're showing here was modeled in-house, maybe even 99%. The general point being is that at this time, the industry still does not have a very robust library of these families that are used for the visualization, the walkthrough as we're doing here in Revit, and the drawing symbols and so forth. Some are very good. I'm not going to point that out for favoritism reasons. This $7 million contract value, and that's the food service scope contract value, is part of a larger $15.7 million in total contract value for food service that we've done that had some type of BIM scope to date. And yes, the bulk of this value was in some type of design build form. And this project is a perfect example of a design build type construction deliverable for the client. One guaranteed price from the general contractor, who then gets all of the consultants and subtrades in line to build it. And definitely this is one of the highlights of these tools as far as marketing and visualization for a client, to be able to show the client exactly what you're going to get instead of requiring them to try to interpret what their project or what you're trying to deliver is going to be in its end form from, say, 2D plans, elevations, and sections. Sometimes you need a little bit more photorealistic images to really convince the people of what you're going to give them is going to be in their interests so that they can open up their checkbooks. And these following images were done with 3ds Max and are the best we can produce to show a photorealistic idea of what exactly the project is going to look like at the end. And really, these images can only be done after you have a very robust library of components in Revit with the details so that they can be exported to this other animation program, 3ds Max, which is much why they're being shown last. You can also do animation fly-throughs. This was also done with the 3ds Max program, with most of the modeling done in a Revit, which was then exported. Some of the little fine details are then picked up in Max, or where we have a little graphical issue. And then we add the materials and lighting. To do this, we have to combine a number of computers together for a render farm. And this little animation, when you see it at the end, in total took 2 weeks on my render farm as it is now. What that 2 weeks measures is actually after the scene is completely set up with lighting and materials and all the objects, then you hit render, and 2 weeks later you get all the frames out, which you get to put together. So what that is that's 2,150 still frames, which then get all spliced together into this nice little animation. I hope that in conclusion that this video helps show some of the potential of these new programs and tools for the food service industry, and also hopefully enlightened a little bit as to the costs. Again, to all of you in attendance, thank you very much for your time on this presentation of BIM in the food service industry.